Today is April 22nd. As people around the world celebrating Earth Day today, I'm going to go over the physics of wind turbine. When you talk about physics of wind turbine, we are talking about how wind turbine uses the kinetic energy to turn it to electric energy. Now the question is, how wind turbine uses kinetic energy? Well, a moving mass has a kinetic energy. So wind or air has mass. So the blade of wind turbine creates swept area or creates a circular path. You can imagine as a bucket being swung with constant velocity creates a circular motion. So three blades also create circular motion which has a swept area. What am I talking about? Let's draw it. These three blades creates a circular path which has a swept area. This mass or wind moves length L with velocity v. That's going to take us to the physics. Okay, now what do we know about the kinetic energy? We know that the kinetic energy, and we know the power of wind turbine. The power is W over T. Okay. Now we're going to replace W by half mv squared because W is also half mv squared. So now P is equal to then mv squared over 2T. Now when we talk about the mass, what are we talking about? Let's draw the diagram again. Through the swept area A, length L with velocity b per second. Okay, now then what is mass? The mass is simply equal to the swept area and the rho. Rho is the air density times the L. This is the mass. So the mass passes through this swept area per second, and this is the equation for mass. Now we can replace this by that right here. So P is equal to m should be replaced by this. So A rho L v square over 2T. Now you notice L over T. What is L over T? L over T is the velocity. So we're going to write rho power is equal to A rho L over T is the velocity, and then velocity square over 2. Now this is the equation for wind turbine. A rho velocity square over 2. Velocity cube, because velocity and velocity squared is velocity cube. Now we're going to find the area. So what is given? Few things are given. So the diameter of the wind turbine is also given. So the diameter is 90 meters, and the velocity of the tip of the wind turbine is 12 meters per second, and the air density, which is the rho, is 1.25 kilogram cubic meters. So these informations are given. So what we need to find? We need to find the power of wind tunnel. So let's see, we can use this formula. We can use the mass. So the area is equal to pi r square. So we don't have the r, but we have the diameter. So pi d square over 4. So what we essentially have 3.14, diameter is 90 square over 4, 6359 square meters. So now power is equal to 6359, rho is 1.25, the velocity is 12 cube, and then the 2, 68677 2. This is the physics of wind turbine, and this is an example.